Okay? Those are the two fundamental ones. Now let's go ahead and take a look at the next one, which is called the scalar multiple rule. If we go ahead and take a look at the scalar multiple rule, this says what happens if you have a function and then you multiply it by a number. Okay? How do you take the derivative of a scalar multiple of a function? So what this says is you just take the derivative of the function as normal and just multiply it to the scalar. Multiply the scalar to that derivative function, derivative of the function. So let's say, for example, we have a function that's called, let's say, for example, 3x squared. Now, let's just double check to see if everybody's clear as to what this represents. Okay, let me go ahead and write it this way. Y is equal to c f of x. So notice that the f of x is actually x squared in this case, and the constant is 3. How do you use this rule? It says that y prime is going to be equal to 3 times it by the derivative of the function f of x. So this is actually what f of x is, was x squared. Well, that's the power rule, we just did that. So that's going to be 2x to the first. So we can simplify that to just 6x. Very straightforward. Now let's go ahead and try another one. Let's say, for example, we do negative 4x to the fifth. Well, y prime is going to be negative 4 times it by the derivative of x to the fifth. So that means that that's going to be 5x to the fourth. So the answer for the derivative is negative 20x to the fourth. Now let's try just one more. What happens if we have something that looks like this then? Negative 1/2 x to the 1/2. Okay, well, here's our constant. Here is our function f of x. So that means that y prime is going to be negative 1/2 times it by the derivative. Oh, let's change this to a 1 actually. Let's change that to a 1. Negative 1/2 times it by 1x to the 0. So that would then be just negative 1/2. And so there you go. Very simple how to use the scalar multiple rule, so long as you can recognize what you are actually trying to differentiate. Okay, the last one that we have is this. Y is equal to f of x plus or minus a g of x. Now what does that look like? Okay, of course the derivative just says take the derivative of this here, plus or minus, nothing changes there. And the derivative of g of x, which is g prime of x. So let's think about a situation that actually looks like that. Let's say, for example, y is equal to x squared. Let's just go plus x to the third. Okay, if we wanted to go ahead and find the derivative of that, y prime, all it says is that I have to just take the derivative of this, which we already know via the power rule. That's just going to be 2x to the first. And then plus, nothing changes with regards to the sign. And then we just take the derivative of x to the third, because that's the other function. So that's just going to be 3x squared. Okay, and you're done. Okay, let's try one more. Let's say y is equal to, let's make this a little bit more tricky here. 1/2 x to the fourth plus, let's make this a minus 4x to the negative 2. Okay, well, let's see if we can actually do this now. Well, what we can see here is that that is just going to be the 1/2 x to the fourth. Now, how did I go ahead and differentiate 1/2 x to the fourth? That is going to be using the scalar multiple rule and the power rule. So that's going to be 1/2 times it by 4x to the third. The sign doesn't change, so it's minus. And then I have a minus 4, right? Because it's going to be, again, the scalar multiple rule with the power rule. That's going to be negative 2x to the negative 3. Okay, and then after that, it's just a matter of simplifying, and you can come up with your answer. So, notice that what you're going to do is you're going to base everything upon these 3 rules for right now. And if you can determine whether you're dealing with a constant, whether you're dealing with a power rule, or if you're dealing with, say, for example, a constant multiplied to the power rule, then you can just take a look at each one of the terms and differentiate each one of the terms, which should look like something like this. You can just differentiate each one of the terms to differentiate the sum or difference of two or more functions. Okay, so let's just take a look at one last one. And hopefully you can actually do this on your own now. So let's just say that this is going to be 3x to the fourth plus 2x to the first plus 5. Let's put a minus in there as well, just to make it a little bit more interesting. So what is the derivative of this? Again, first thing, this is how you should look at this. I need to take a look at the derivative of 3x to the fourth. 3x to the fourth is really the scalar multiple and the power rule together. Okay, then I have to go ahead and take a look at the derivative of plus 2x. This also is going to be the same thing as the scalar multiple rule and the power rule. Then I have to go ahead and take a look at the derivative of minus 5. Minus 5 is the constant rule. Use the constant rule. So what I come up with then is y prime is going to be 3 times it by, this is 4x to the third, plus 2 times it by 1x to the 0. And then, of course, the derivative of a constant is 0. Okay, so what we come up with then, y prime is going to be 12x to the third plus 2. And you are finished. So notice that what we can do is we can very simply find the derivative function given any function, so long as at this point it only deals with a constant, a power, or a scalar multiple, or a sum or difference of functions. Okay, and there you go. That's what we're going to be practicing the next time that we meet. Okay, so give it a shot. Section 21D, simple rules of differentiation or finding the derivative of the function f of x. Okay, good luck. Bye-bye. Okay, hello everyone.